kids, this is the classroom lecture for Friday, November 2nd. We're doing this by video because today I'm down at Southwestern Assemblies of God University in Waxahachie. My oldest child and I are busy looking around the campus during college days to see what's going on there. So get to come to you almost live and in person. It gives you the flexibility to watch this lecture at your convenience without having to be up at co-op. Gives me the flexibility to be able to do some needful things for my children and not have to miss class for you guys at the same time. So let's go ahead and pray and get started. Father God, I thank you for your goodness to us. Lord, I thank you for all of the things that you have enabled man to understand and create and work within this wonderful world that you've given to us, so that we're able to do things like record videos and upload them into whatever this space is that we call the internet, and my students are able to watch from remote locations at their home or in a library or even on their iPhones. Father, I ask that you would help this time as I present a lecture, help it to be clear, help their minds to be focused, and help them to accomplish the things that they need to do. Bless their week in Jesus' name, amen. Okay. Where do otters come from? Well, otters come from outer space. And then got this other one, it's just ultra lame. What happened to the wooden car with the wooden wheels and the wooden engine? Well, it wouldn't go. Okay. So since you are not meeting class at co-op, you may be wondering what in the world were you supposed to do with your homework? Your homework that was due for today, November 2nd, was to complete section 3.8, 3.9, the chapter 3 review, and section 4.1. You were also to have completed test number 3 and brought that into class. Obviously, you cannot hand those in to me today since I'm not there with you. So what you're going to do is bring that homework with you next week, which is November 9th. So we'll collect that homework as well as the work that's going to be assigned to you this week. You have 4 more sections to do: section 4.2, 4.3, 4.4, and 4.5. Once again, that's a lot of material for me to fire hose at you to try to give to you in just one class. But as always, those videos are linked for you to go through and watch each individual section teaching. And by the time that you're watching this video, those links will be live on the ARC class page. So just go ahead and proceed just as if I actually were here in class with you today. Let me see what else. We have a help class scheduled. If you look at your assignment calendar, you see that we have help class scheduled again on next Monday, which is November 5th. That's at my house out here. And the time for your class is from 10:45 till noon. I'd really appreciate an RSVP if any of you guys think you're going to come. I'm available to you. As always, it's totally optional. If it's helpful, come on out here. If you get stuck, come out and work with me, and you can always text me, email me, call me. Someone has started sending me emails, and emails are fine, but that's the slowest response that you're going to get from me. First priority would be to shoot me a text. If you don't get an answer within an hour, send me another text, leave me a voicemail, or you can go ahead and put it on an email, because I'll usually I'm on my email once a day, but not always, because sometimes my days just get busy. Okay, let me see. Next week it is notebook check. Today is November 2nd, so I should be checking your notebooks. Obviously I'm not, since you're watching me on video. Next week we're going to come around and we're going to check your notebooks. If you don't remember what in the world your notebook's supposed to be including in it, make sure you go ahead and get that page out that was handed out to you. It says notebook requirements. If you forget what that is, go ahead and look at the ARC website, and I'll have a link to that on your class page. Looks like that's what we have for right now. what I want to address first is section 4.2 in your book, which is found on page 136. And we're going to be spending some more time talking about word problems. We're just really beginning to get into them, and a lot of times word problems are what just terrify people. In math, they think, oh my word, I'm reading this long thing, I have no idea where I'm going. Well, in our text it talks about, well, let me go ahead and read this to you. It says, when a problem arises in your life, how do you solve it? Do you hide your head in the sand and hope the problem will go away, or do you consider it unimportant? Do you worry and fret, or do you plan a solution to the problem and attempt to put it into action? And then they've got a little picture up in the corner of your text, which I've never actually seen before, just heard about it. The world's largest bird hides from hunters by burying its tiny head. Do you hide from word problems like an ostrich? Which is just really sort of stretching things. People that don't like word problems don't hide from them, they just run away from them. But then the authors of the text go on and talk about how, for me, that every part of our lives, every part of our studies, you tie that back to this God who created us, loves us, has a plan for our lives, and has just created a world that's filled with order. So they go on and they say, Christian must always be prepared, especially against the craftiness of the devil. Ephesians 6:10-18 tells the Christian how to prepare himself to overcome the problems he'll encounter. He must put on the armor of God before he goes into battle, and he cannot defeat the enemy unless he's prepared. I want to take just a second to encourage you guys to be visiting with one another. Surround yourselves with godly friends. Stay in God's Word. Believe God's Word. You use the weapons that He gives us to fight against the attacks of the enemy and to be prepared for things. Walk in His strength. Ask Him to give you ears to hear Him speak to you. And just be bold to step out in what God would have you do. This is something that I've been talking a lot about lately with a few women that God has me in relationship, and a whole lot to do with being prepared. Just like we want to be prepared, we want to know God's Word, we want to be aware of the ways in which the enemy will attack us. If you're prepared to go on a trip, if you prepare your lunch, you prepare your homework, you prepare yourself with some basic information on word problems, you got a plan of attack, and then they're not near as difficult as they could be otherwise. First off, and these things that we've taken from your text are really intuitive and reasonable things to put down. We don't always think about it. So what are they saying? Well, the first thing you want to do is read your problem carefully. Maybe read it a few times, but read it carefully. And what's involved in reading something carefully? Well, first off, read it slowly enough so that you're not skipping words. Secondly, make sure that you read your word problems the whole way to the end of the problem. All of us, kids, adults, the whole thing, when we get in a hurry, or sometimes we think we come to a conclusion that we understand exactly what's being asked, we'll stop reading before we get to the end of the problem and we'll start to work something. Or we'll be talking with someone and we interrupt them at a certain point and say, oh yeah, I know you want me to do da-da-da-da-da. And they say, well no, if you'd let me finish, what I actually need you to do is I don't need you to change my tire. I want you to go get me the air pump because it just needs to be filled up. It doesn't need changed. So we have to make sure that we read the entire problem carefully, figure out exactly what it is they're asking for. Sometimes you can draw a picture that will help you to understand what the word problem is saying. Then you need to go ahead and assign a variable to the unknown. Like for example, this example here, it says the sum of 5 times the number and 2 times the number is 161. Find the number. What are we looking for? We're looking for a number, so we're going to assign a variable. A lot of people use n, that I just use x for anything I'm going to find, but we'd say let n be the number. Okay, you've read the problem, You've assigned a variable to the quantity that you're trying to find. The next thing that you want to do is develop a plan. There's an old saying that's been around since I was your age, like 95 million years ago, that says if you fail to plan, then you plan to fail. That's true in work, that's true with your homework, with your chores at home, that's true with doing word problems. It's just true with life. If we just go about without an idea of a method of attack that we want to use, we can sort of wander around aimlessly. So you're looking at your word problem that you just read, now you say, okay, exactly what can I do to solve this? Sometimes you're going to want to make a table. That doesn't make any sense to you right now, but this particularly shows up with mixture problems, with distance problems, and rate problems. And I'll teach you how to make a table. And then we've been doing a lot of practice where we're translating from English into algebra, where we have just phrases. Last week we learned how to make a complete equation and how is, the English word is, translates into an equal sign. What we have over here on this side of the equation is equal to what we have on the right side of the equation. That's how we set up our algebraic equations. So we're going to translate our English into algebra. We've got that equation that we've set up, and we're reading our problem very carefully because we need to come up with two different expressions or two different quantities that are equal. We set those quantities equal to one another, and then we're going to solve that equation using properties of equalities and all of the methodologies that we've learned using the ideas of multiplicative inverse, additive inverse, the fact that as long as you perform the same operation on both sides of the equation, that equation remains balanced as if it were a seesaw. And even though it looks different, you can go ahead and continue to solve that equation more readily because it looks different, but the relationship between both sides of the equation remains the same. Finally, the last thing that you're going to want to do after you arrive at a solution to the equation, you want to take the time to go back and check. What are you doing when you're checking? Well, first off, you're making sure that this number that you arrived at, like 17, 17 what? 17 inches, 17 miles, 17 cats, is 17 the number? Make sure you can't just stick a number out there, you have to tell me what it is. Second thing that you want to be making sure that you've answered is what questions are they asking in the problem? Something that happens very frequently is it will say, for example, the sum of a number and twice the number is equal to 110. Find the numbers. Kids and adults will say, okay, well, see that a number and twice a number is 110. See, I created one off my head that I can't do. How about a number and twice a number is equal to 90? They'll go ahead and solve that and say, oh, well, the number's 30. They've only answered half of the problem because the question said the sum of a number and twice a number is 90. If all they tell me is that 30 is the number, they have not answered the question. Now, just as a reminder, when you're solving word problems, you don't just come up with the answer like I did here. I did this because I'm creating a problem in my head that I can illustrate the answer to. So have we answered all of the questions that they're asking us? What are the numbers? Well, the numbers would be 30 and 60. Then the last thing that you want to do is the answer reasonable? Now, obviously, if we have two numbers that we're adding together that's equal to 90, and we get negative 30 and negative 60, that's not reasonable because they're negative numbers. It's not going to end up being positive. Just like it would not be reasonable to say that John, when he was running 2.5 miles every morning, that he completed that 2.5 mile run in 3 minutes. You know, you're looking to make sure that your answer makes sense and that it's reasonable. So I'm going to go ahead and use this example right here that I made up just to illustrate a quick little word problem. We're looking for the sum of a number and twice the number, and that's going to be equal to 90. So what do we want to do first? Well, we're just assigning variables. So we can say let n equal the number. So what are we adding together? We're adding a number and twice a number. So if n is the number, then 2n is going to be twice the number. And I said the sum of a number and twice a number is equal to 90. What is sum? You know that sum, S-U-M, is addition. So the sum of a number and twice a number is equal to 90. We're going to collect like terms. What are like terms? They have the same variable, same expression. You add the numbers in front of them, which are the coefficients. There's not a 1 in front of the n, but we understand that when it's just n by itself, it means 1. 1 plus 2 is 3, n is equal to 90. Well, you know that 3 times 30 is equal to 90. Show me what you're doing. We're using the principle of multiplicative inverses. We have n that we started with. We've multiplied n by 3. We know that division is what undoes multiplication. So if we divide both sides of this equation by 3, it looks different now, but the equation is still in balance because we have taken the left-hand side, divided it by 3, taken the right-hand side, divided it by 3. We've performed the same operation on both sides of the equation. So it remains in balance, and you have n is equal to 30. Now is that the final answer? No, because it's asking us first to find a number and twice the number. Is equal to 60, so you could say the numbers are 30 and 60, or something like this. This was a very, very straightforward, simple word problem that I didn't even step through. Read, plan, solve, and check, but we talked through it on your video for section 4.2. It goes into much more detail than this, and since I'm trying to fire hose you real quickly here, that's the end of section 4.2. Okay guys, we're going to go ahead and continue now with section 4.3. This is page 140. We're talking about solving equations that are in the form ax plus by, two variables. Ax plus b is equal to c. And an example of this would be 2x plus 6 is equal to 21, where we have a, which is the 2, we have b, which is the 6, we have c, which is a 21. They're real numbers, and then we've got a variable. So this isn't anything different than what we've done before, except it's a two-step problem. What you've had before might have been like 2x is equal to 17, and you had to divide both sides by 2. Maybe you had x plus 3 is equal to 19, and you had to subtract 3 from both sides of the equation. This way we have two different things that are going on. So we have our little algorithm, which is our plan of attack that says, what are we going to do when we have an equation that is a variable, we've got constant terms set equal to another constant term. Well, the first thing that you always want to do when you're solving any sort of an equation is you look, are there any like terms that you can combine? If you have 2x plus 3x, you can't go any further until you realize that those combine 2x plus 3x is equal to 5x. So first we look, do we have any like terms here? No. So we go ahead on to the next step. And what we're doing when we are solving equations, so there's a term that you'll hear a lot, it's called isolate the variable. I'm looking to see if there's any place on here where I can write it. Not really, so I'll put down here, what we're doing is we are isolating the variable. What we have set up here, this equation 2x plus 6 is equal to 21, that's telling us that this whole expression 2x plus 6 is the same as 21. But I don't really care about that. I don't care about what 2x is equal to. The part that I don't know is what is x itself equal to. So what I'm going to do is perform a variety of operations on this equation so that I can isolate the variable, so that I can figure out what x all by itself, what the value of x all by itself is. So what we're trying to do is we want to eventually continue down through these steps until the variable is all alone by itself on one side of the equation. So first thing that we do, we've checked for like terms. There are no like terms in this problem. And then we're going to say, okay, what operations have been performed on the variable? In other words, what's going on? Well, here it's been multiplied by 2, it's been doubled, and it has had 6 added to that product. If we want to get the x all by itself, we're going to have to get rid of that plus 6 first, aren't we? But what's been done? 6 has been added. We began with 2x. We've had 6 added to it. The inverse operation for that is subtraction. So we have 2x plus 6. Since the inverse of addition is subtraction, we've added 6. We're going to subtract 6 now from both sides of the equation. Why do we have to subtract it from both sides of the equation? Because you have to keep that relationship between the two sides in balance. And you do that by performing the same operation on both sides of the equation. Okay? You see this now? We've subtracted 6 from both sides of the equation. The next thing it's going to say, see, I've already done, we've performed the inverse operation on both sides of the equation. We've added 6, so we're going to subtract the 6 from both sides of the equation. Now, next step is we simplify each side. What can we do here? We have plus 6 minus 6 is equal to 0. So we have 2x is equal to 21 minus 6. You should be able to, I would expect, look at that and know that the answer is 15. If you want to go ahead and show your subtraction, that's perfectly fine. But have this scratch section off to the right-hand side of your page. And this is where you're actually doing your computation or your work. Don't do 21, this columnar subtraction, don't put that over here. Just show me that 2x is equal to 15. And see, we've gotten closer. Now, instead of saying that 2x plus 6 is 21, we're getting closer to having the x all by itself. Remember I said we want to isolate the variable? Let me see, is that even, I'm looking here and I think all it says is isolate. What we want to do is isolate the variable. That's what I get for not verifying that y'all can see what I'm doing. So we want to isolate the variable. Now we have 2x is equal to 15. Don't care about that. I want to know what 1x is equal to. So I'm going to have to do this again. Any like terms? No. What operation has been performed on the variable? I started with an x. What did I do? Multiplied that value by 2. What's the inverse operation for multiplication? The inverse of multiplication is division. So we're going to divide the left-hand side of the equation by 2. To keep it in balance, what you do to the left-hand side, you also do to the right-hand side of that equation. Now, simplify both sides of the equation. 2x divided by 2 is x. X is equal to 15 halves. This is your answer. Do not change that for me into 7.5. Leave your answer as a rational number. Remember what a rational number is. Looks like a fraction. It's a numerator over the denominator. Has to be reduced to lowest terms. Means you don't have any common factors. If this 15 is 3 times 5 divided by 2. There's no factor in common, so this is in lowest terms. We've combined like terms. We've figured out what operations were being performed on the variable. We have undone those operations by using 2 steps where we applied the principle of inverse operations. We've simplified and we figured out now finally that just one single solitary x by itself has a value of 15 and of 15 halves. Now what we need to do is check. How do you check? You take the number that you arrived at for the value for x. You're going to substitute that back into the original equation and see if in fact it's true. So let's go ahead and clean up this board and do our check. Remember we said that x was equal to 15 halves. So we're going to substitute 2 times 15 halves plus 6, is that equal to 21? All I've done is substituted in the solution that was down here in my problem where I said that x was equal to 15 halves. I've substituted that in for the original location of the variable. Now I'm going to do the arithmetic on this. 2 times 15 halves. 2's cancel. We have 15 plus 6. Is that equal to 21? Yes. 21. Not 12. 21 is equal to 21. If you're not sure about 15 plus 6 in your head, off to the right-hand side of the paper is your scratch area. 15 plus 6, 6 plus 5 is 11, carry 1, 21. That's how you solve equations of the form ax plus b is equal to c. Go ahead and look at the teaching video for section 4.3 for some more examples. Okay, we're in section 4.4 now, doing more practice with equations, and this is where it says you just have to work the problems. You cannot just simply watch me do a problem or 2 or 3 in class, go home, do 1 or 2 problems, and know that you can solve equations easily from then on. It takes practice to solve them To be successful in algebra, Algebra 2, higher level maths, you have to spend the time practicing and learning how to work the problems. Here's an example of ax plus b is equal to c. We just have quantities that include variables set equal to a whole number. So the first thing that we want to do to solve this is see if there are any order of operations that we have to solve. Well, yes, there is. We have the distributive property here, don't we? Now, according to our order of operations PEMDAS, it says solve those complete the operation within the parentheses before you do anything else. Well, can you add x and 5 together? No, you can't. If this were 2 plus 5, then you would combine them to come up with 7, but you cannot add x and 5 because they're not like terms. But we have the method that we use to work around that situation. It's the distributive property. So we're going to say that 4 times x is equal to 4x plus 4 times 5. And then we have minus 3x is equal to 24. We've used the distributive property here. We've taken this outside factor of 4 and multiplied it with each of the terms inside the parentheses. 4 times x plus 4 times 5 minus 3x is 24. 4x plus 20 minus 3x is equal to 24. What's the next step that we want to do? Remember we had these steps that we stepped through? Well, we're always going to look for like terms. Aha, I have like terms. I have a 4x minus 3x. You keep the variable, you add or subtract the coefficients as necessary. If you have 4 apples, you eat 3 apples, you have one apple left. You have 4x, you subtract 3x, you have 1x left, plus 20 is equal to 24. Now you heard my mouse say we had 1x left, and my hand wrote x. Don't write 1x. We understand that if there is no number, no coefficient in front of the variable, we're just talking about 1. Now, when we are solving these equations, remember, we don't care that 4 times the quantity x plus 5 minus 3x, all of that lumped together is equal to 24. We don't care that 4x plus 20 minus 3x is 24. What we're trying to figure out is what is the value of one single solitary x all by itself. So we want to do enough arithmetic, well, enough algebra on this equation so that we end up with the x or the z or the m, whatever letter you're using, so that we end up with that by itself on the left-hand side of the equation. So we have just 1x by itself. What's been done to it has had 20 added to it. So the inverse operation for addition is subtraction. So we have x plus 20. We've added 20, so we want to subtract 20 to undo that operation. Then we have that's equal to 24. Is this all we have to do here? No, my equation is not in balance. Don't forget, whenever you do something to one side of the equation, you have to do that identical thing to the other side of the equation. Then your equation remains in balance and you're just fine. Subtract 20 from both sides of the equation. We have as our solution x is equal to 4. And then the book says, go ahead and check this mentally. It's perfectly fine to check this mentally, provided you're comfortable with what you're doing. I'm going to step you through it. What does this say that x has a value of? X has a value of 4. So let's see what would happen. What you would want to do is you would, every place there's an x, you're going to substitute in a 4. So you're thinking, okay, 4 times 9 minus 12. 4 times 9 is 36 minus 12 is 24. That's the mental check to it. If you just assume not do it that way or you're not quite comfortable, go ahead and take the time and write a few of these steps out. So you have 4 times 9 minus 12 is 24. Actually, is this equal to 24? This is what we're checking. We don't know for sure that it is. 36 minus 12 is 24. And you might recognize this as 3 dozen eggs minus dozen eggs gives you 2 dozen eggs. If you're still not real fond of mental math, show your calculations over on the right-hand side of the page, and you have 24 is equal to 24. Nothing different from what you've been doing all along, it's just we're adding more steps to it. Problems are getting a little bit longer. There's one more thing that I want to show you, take the time right now today to show you from section 4.5. Like, you know how to convert, how to reduce 16 over 20. You know, maybe you can see that right away as 4/5. But if you would prime factor this, or not even prime factor, 16 is equal to 4 times 4. 20 is equal to 4 times 5, isn't it? So I put that equal sign in there. Let me say the next step down here would be 16 is 4 times 4. 20 is 4 times 5. You cancel common factors. And you arrive at 4/5 for your solution because you know how to work with something like that. Well, sometimes you have to convert decimals. Let's say that you had 0.75 and it said convert this to a decimal form. What does 0.75 mean? Well, it's 75 hundredths. 75 hundredths can be written as 3 times 25, 4 times 25, and you simplify 75 hundredths to be equal to 3/4. Sometimes, though, you're going to have a repeating decimal that you have to simplify. And what are you going to do with this? So here's this example here from your book, and this says convert 2.3 repeating. Convert 2.3 repeating to fractional form. And the key to being able to convert these repeating decimals to fractional forms is figuring out a way to be able to subtract the repeating pattern. So it's sort of a little bit of a trick here, but you're going to say, let's let x by itself, all by itself, be your original repeating decimal. And then what we're going to do is multiply this repeating decimal by either 10 or 100 or 1,000, whatever you have to do, so that we get one complete set of what repeats. We move that over to the left of the decimal point. Let me show you what I mean. We only have a 3 repeating. So if we multiply 2.3 by 10, it's going to become 23.3 repeating, right? Because this is just 2.33333, on and on and on forever. So you can just move that decimal 1 point to the right, and we have all of our 3's lined up. Let me show you this. 23.3 repeating minus 2.3 repeating. What happens here is that now we have lined up to the right of the decimal point a bunch of 3's forever. And you can subtract and you end up with 21. on this side of the equation right here, we're subtracting, we end up with 21, but watch how this actually works. Let's say that 10x, I'm going to put this line here, 10x is equal to 23.3 repeating, x is equal to 2.3 repeating. Because these are both equal on the left-hand side of the equation and on the right-hand side of the equation, they let you subtract one equation from another. It's sort of a strange thing to do, but they want you to understand how to do this. If you have 10x and you subtract 1x, you have 9x. I just illustrated to you what happens when you subtract these two repeating decimals, and you end up with 21. Now you have an equation that you recognize where you've multiplied x by 9. We're going to apply the inverse operation, which is division. So we're going to divide both sides of this equation here by 9 to keep it in balance. You have x is equal to 21 over 9. Is this reduced to lowest form? No, it's not. It has a factor of 3 in common, so when you finally finish reducing this, you have x is equal to 7/3. Because 7 times 3 is 21, 3 times 3 is 9, you have a common factor of 3 that cancels. They're going to expect you to be able to understand how to convert a repeating decimal to a fraction. I'm going to have this be a bonus on the test, so it's worth your time to figure out how to do, but it's not a big enough deal that I'm going to have it be a part of your regular test. Okay, so we've got one more little section to do. Let me pause the video again. Okay, we're back for the very last part of this. Now, excuse me as I talk, figure out what in the world happened to my camera there. Who knows? I'm going to go ahead and set my timer right now for about 6 minutes. I am totally almost out of time on this. Of course, that is nothing surprising to you because you know that I run out of time every class period because there's just simply no way that you can cover all of this material, which is why I call it just this fire hose approach that we do, and I provide the other videos for you for each section so that you can go ahead and make sure that you at least have a little bit more teaching time. This is the last section that we're working on, which is section 4.5. This is where they talk about solving equations that have the form ax plus b is equal to cx plus d. And I know it sounds weird when the only thing that you're using is letters, but that's just a pattern that they're showing you. What's the difference between with this equation and what we did just a few minutes ago? The other difference is that you have variables on both sides of the equation. So we're adding one more step into the process. Remember that all we're trying to do with these equations is to figure out what the value of one single x is all by itself. So if we're going to be able to combine like terms, which of course includes the x's have to be all on the same side. So typically we're going to want to have our variables on the left-hand side of the equation, especially at the beginning, because our minds are sort of wired. We're programmed in America, in English, to read from left to right. So we're going to go ahead and put the x on the left-hand side of the equation. How are we going to do that? Well, we're going to see what we have that has happened. We have x minus 2. We've added an x. That's a positive x. Remember, you don't see the plus, but it's positive. If we've added an x on the right-hand side of the equation, we can subtract an x on the left-hand side of the equation. On the right-hand side of the equation. You have plus x minus x, the x's go away. We've subtracted an x from the left-hand side of the equation. We want to subtract an x from the right-hand side of the equation as well. What do we do now? Since we've subtracted x from both sides of the equation, our equation is in balance. Now we collect like terms. 2x minus x is x plus 5. X plus 5 is equal to x minus x is 0 minus 2. Now we have an equation that looks more like what you're accustomed to seeing. X plus 5 is equal to 2. We want to isolate this variable, and what are we going to do? We say, well, what have we done to it? We've added 5. The inverse operation for addition is subtraction. So since we added 5 to the x, we're going to go ahead and subtract 5 from both sides of the equation so that we can get our x all by itself. X plus 5 minus 5. Finally, we now have isolated the x. We have just one single solitary x all by itself. We have negative 2 minus 5 is equal to a negative 7. And you can remember that if you're trying to figure out how to subtract negative numbers, subtraction is the same as adding the opposite. Negative 2 plus a negative 5 gives you a negative 7. Our solution here tells us that x has a value of negative 7. What do we do to make sure that we have the right answer? For our check, you go ahead and take that value of a negative 7 and substitute it back into the original equation every place you have an x. Negative 7 minus 2. And you say, if I give a value of negative 7, if I assign that to every place there's an x, is my equation going to still be true? 2 times a negative 7 is negative 14 plus 5. Is that the same as negative 7 minus 2? Subtract the smaller absolute value from the larger absolute value, keep the sign of the larger. Negative 9 is in fact equal to negative 2. So this is all that you're going to be doing in section 4.5, is adding the extra step of making sure you have all of the variables collected together on one side of the equation. You see how much time I have left? I've got 1 minute, which is not going to give me enough time to do anything. This video that I'm recording for you should be just about 50 minutes. I have 51 minutes total possible on this. Let me take this last 45 seconds or so to remind you of what you need to have for me next week, which is November 9th. You've got to have your homework that was due today, November 2nd, and that is section 3.8, 3.9, the review, and especially test number 3. Make sure you've brought all of that. Your homework for this week is section 4.2, 4.3, 4.4, and 4.5. So you have quite a whole mass of papers that you're going to be handing in to me. Section 3.8, clear through section 4.5, in addition to the chapter 3 test. As well as that, remember, we're going to check your notebooks when you come into class next week. Make sure you look at your notebook page that tells you exactly what you should have in your notebook. And then the final reminder here is that next Monday, which is November 5th,